Hi, my name is Walker Reed, and this is Physics Lab 4, Spring Oscillation. So, for an introduction, in this lab we are examining the motion of a spring mass system while it swings in an arc and oscillates at the same exact time. The fundamental principles that we are using is Newton's second law and the energy principle, and the systems involved is the mass, the spring, and obviously the earth. Here are some formulas that were used for this lab, including the velocity update formula, position update formula, kinetic energy formula, gravitational potential energy, spring potential energy, the total energy, which is when you add all of them together, and the spring constant. So to start the experiment, we had to track the video from online using the tracker. You can see that I started with the calibration stick to measure the distance from where it was being held to where the spring was let go. And then after that, I tracked the motion with all of the dots. And then on the right side, you can see the graphs that it generated as it started to lose energy on the top. And then in the bottom right is the table that it generated with the time as well as the x and the y position. So to start for the code, we had to initialize the position and velocity. So obviously it was dropped from rest, so the velocity stayed at 0, and the position is again what was generated from the tracker app, as well as the mass, which was 0.402 kilograms. And my delta t I just left as the 1/210. For the next part of the code, we needed the spring constant using the formula shown on the previous slides. The relaxed length of the spring, which I used with the calibration stick, and what I had shown in the video. The L hat, S, and then typed in my equations for the kinetic energy, gravitational potential energy, spring potential energy, and then total energy. And then for the last part of the code, very similar, inputting most of the formulas for the force of gravity. Spring formula is where we also use the velocity and position update formula, as well as updating the movement of the spring and then calculating how the energy was going to change throughout the video and during the system. So here are the results. As you can see, I wasn't able to get my experiment super accurate. I kept trying to mess with some of the numbers and formulas in the code, but it seems like the positions were just a lot more off than they should have been. I'm not sure exactly where it went wrong, but again, there was just some mistakes with the code that I ran. It does move in a similar pattern, but obviously the numbers are pretty far off. What does it mean? Again, I wasn't able to work with the code in the tracker app to get them lined up exactly. And it just seems that the difference was how far up and down the spring mass was moving. So it must have been some sort of issue with one of my spring or energy formulas that just didn't calculate correctly in the code.